Okay, here we'll see one question. Transverse waves are generated in two uniform wires A and B of the same material by attaching their free ends to a vibrating source of frequency 200 Hz. So it means frequency is constant. The cross sectional area of A is half that of B. Cross section of area is A is half that of B. So A, listen. So cross section area of capital A is A1, and that is half that of B. Half that of B nothing but this I am taking it as AA is equal to AB by 2. So AB is as it is. That is the meaning of that. AB is as it is. And now the next one is see here. While the tension of on A is twice that on B, tension in A is twice that of B. TA is equal to 2 TAB. TA is equal to 2 TB. Okay, and now, so based on these models, based on these given data, here we are taking further. Okay, so what is that? What we need to calculate? The ratio of the wavelengths of the wavelengths of the transverse waves in A and B is. Okay, so now here we need to calculate lambda A by lambda B, ratio of wavelengths of waves in A and B. Lambda A by lambda B equal to question mark. So here we are taking the formula V is equal to root over T by mu. That is equal to root over T by, previously I said to you that mu is equal to mass by length. Mu is equal to mass by length, and that value itself is taken as mu is equal to mass is equal to what's the form? Density into volume by length. Mu is equal to density, volume is nothing but what? Area into length by L. So that's why here length get cancelled. Mu is equal to, we used to take it as rho A. This is another formula of mu. Mu is equal to mass by length as well as rho into A, density into area. Now here I am taking the concept it as density into area. Okay, so now here density of the same material means density is constant. That's why here we are taking the concept it as V is equal to, general formula is what's the V? V is equal to n lambda. N lambda is equal to root over T by rho A. Now I require the lambda. So lambda proportional to root over T by A. Why? Because in the problem tension as well as area, in between these two only the given data is given, right? So lambda proportional to root over T by A. It means lambda A by lambda B is equal to root over TA by TB into area of cross section is in the denominator. So here we are taking that AB by AA. Now by substituting TA value, TB value, AB value as well as AA value, and here you will get the value as the ratio of the wavelengths of two waves in A and B is 2. This is one model, and then another model is, see this, when the stretching force of a wire is increased by 2.5 kg, the frequency of the note emitted is changed in the ratio. And now we will discuss some important questions in waves. So based on that, many times they used to ask in that model. The first thing is nothing but take this question. When the stretching force of a wire is increased by 2.5 kg, so in this case T2 taken as T, and then increased by 2.5 kg, T1 is equal to T plus 2.5, and the frequency of the note emitted is changed in the ratio 3 by 2. So N1 by N2 is equal to 3 by 2 given in the problem. Now here we are taking the formula N proportional to root T. So N1 by N2 is equal to root over T1 by T2. T1 is equal to T plus 2.5, T2 is equal to T. Here what we need to calculate? Calculate the original stretching force. So T value we need to calculate. T is equal to question mark. For that purpose, I consider this is the formula n proportional to root T. So based on that, square on both sides, then this 3, 9, 2 became 4, square root became as cancelled. Then after taking the cross multiplication, you will get it as T is equal to 2 Newton. Okay, then another one related to the sonometer wire, nothing but stationary wave. Listen, the length of the sonometer wire is 90 centimeter. L is equal to 90 centimeter. The stationary wave setup in the wire is represented by an equation y is equal to 6 sin pi x by 30 cos 250 t. So the displacement of the resultant wave is y is equal to 2a sin kx cos omega t in case of standing wave or stationary wave. So y is equal to 2a sin kx cos omega t. K is equal to propagation constant 2 pi by lambda. In 2 pi by lambda, here pi by 30 represents the k, kx. K, compare these two. Pi by 30 equal to 2 pi by lambda, lambda equal to 60 centimeter. Now, we have the formula L is equal to P lambda by 2. Here P is the number of loops. What we need to calculate? The number of loops is. So that's why we need to calculate the P value. L given that 90. Just now we calculated that lambda equal to 60 by 2. With that P is equal to 3, we got that. So P represents what? Number of loops. Okay, so then in the waves we have another important concept that is organ pipes. So in the organ pipes we have a number of models. So one model here given in 2015. So that model is the fundamental frequency of a closed organ pipe length 20 centimeter, length LC, length of the closed organ pipe 20 centimeter is equal to the second overtone of an organ pipe. Fundamental frequency in the closed organ pipe N is equal to V by 4L. So V by 4LC. Second overtone in the open organ pipe. This is the fundamental frequency. This is the first overtone in the open organ pipe. And this is the second overtone in the open organ pipe. So second overtone is 3V by 2L. So these two can be equal, N1 equal to N3. Now what we need to calculate? Here we need to calculate the length of the organ pipe. What we need to calculate? The length of the organ pipe open at both ends. Length of the open organ pipe we need to calculate. So for that purpose, L0, 2 into 20, 40. 43s are 120. L0 is equal to what's the value? 120 centimeter. Then related to the Doppler effect, one problem is given here in Neet 2017. So two cars moving in opposite directions approach each other with a speed of 22 and 16.5. Two cars are moving in opposite direction. Nothing but source and observer both are moving towards each other. At that time formula is the apparent change in frequency of source of sound N dash is equal to what's the form? V plus V naught by V minus Vs into N. V plus V naught by V minus Vs into N. So we need to calculate the N dash here. V is given that in the problem 340 plus V naught 16.5 given in the problem. V naught is equal to 16.5 given in the problem. Vs source 22. Okay, source is moving with the frequency or giving the frequency as 400 Hz, natural frequency. So 340 plus 16.5 by 340 minus 22, source velocity. The natural frequency given in the problem as 400 Hz. After calculating this, then you will get it as 448 Hz. This is one model given in the 2017. Then another model is given in 2018. See this. The fundamental frequency in an open organ pipe. Open organ pipe fundamental frequency is V by 2L. So that I am taking it as 2L naught. Is equal to the third harmonic of a closed organ pipe. Third harmonic, that is N3 is equal to 3V by 4L. In closed organ pipe, fundamental frequency N1 is equal to V by 4L. N3 is equal to 3V by 4L, third harmonic or first overtone. N5 is equal to 5V by 4L, fifth harmonic or second overtone. Why? Because in the closed organ pipe only odd harmonics are available. Okay, so now these two are equal. This is LC, length of the closed. So V by 2 L0 is equal to 3V by 4 LC. What we need to calculate? The length of the open organ pipe. L0 we need to calculate. V cancelled. 2 ones are 2 twos are. 1 by L0 is equal to 3 by 2 LC. In the problem, LC value is given. Length of the closed organ pipe is 20 centimeter given in the problem. So here we are taking that 1 by L0 is equal to 3 by 2 into 20. So L0 is equal to cross multiplication 40 by 3, that is equal to 13.3 centimeters. This is the length of the open organ pipe. So like these models are given in the problem related to the organ pipes as well as Doppler effects. Okay, so one more thing, this is also one important model. Check out this. Check out. If N1 and N2 and N3 are the fundamental frequencies of three segments into which a string is divided, then the original fundamental frequency N of the string is given by. So here, and this is the problem given in IAPMT. So N proportional to 1 by L, it means L proportional to 1 by N. Okay, so three segments. So L is equal to what's the form? Three segments, L1 plus L2 plus L3. L is nothing but 1 by N, L1 1 by N1 plus L2 1 by N2 plus L3 1 by N3, and this is the form. 1 by N is equal to 1 by N1 plus 1 by N2 plus 1 by N3. Okay, and like this, one more model we will discuss. Here see, two waves having intensities in the ratio of 9:1 produce interference. The ratio of the maximum to minimum intensity. This is also one of the important model. Okay. So for that, at first I will give the data related to the maximum intensity and minimum intensity. Okay. So I max is equal to I proportional to A square. Intensity is directly proportional to the square of the amplitude. Okay. I max proportional to A max square. I min proportional to minimum intensity, A min square. A max is nothing but A1 plus A2. A min is equal to A1 minus A2. I1 proportional to A1 square. I1 proportional to A1 square. I2 proportional to A2 square. That implies root I1 proportional to A1, square root on both sides, root I2 proportional to A2. Now substitute A max with this. So here A max is equal to, so how come we consider that? And that is, we need to calculate I max by I min ratio, maximum to minimum intensity. I max by I min is equal to A max square by A min square. That is equal to A max. A max is equal to what's the form? A1 plus A2. A min is equal to what's the form? A1 minus A2. So now A1 plus A2 by A1 minus A2, for both square is present, whole square. Okay, so now two waves having intensities ratio is given. I1 is to I2. I1 by I2 is equal to 9 by 1. These values are given. So with that we are calculating the amplitudes. I1 proportional to what? A1 square. I2 proportional to what? A2 square. It means A1 square by A2 square is equal to 9 by 1. Then A1 by A2 is equal to square root. That is 3 by 1. Square root 3, 9. 3 root over 1, 1 only. So A1 replace with 3, A2 replace with 1. Then here you will get it as A1 3, A2 1. A1 3, A2 1 whole square. Now with that, 4 square, 4 by 2 whole square. Then this is nothing but 2 ones are 2 twos are 4. It means I max by I min is equal to I max by I min is equal to 4 by 1. It means 4 is to 1.